Welcome, I'm Bill Wake. We're here working on a program to compare tunes for similarity, and we've gotten to the point where we can do clusters of things and display the results in a dendogram, but we haven't yet displayed tunes in the dendogram. So let's move on and do that. Okay, so the last thing we did last week was this notion that the cluster, which is it's a stage in our pipeline, the cluster stage. We've got a list of tunes empty right now, and we run the stage through the tunes, and we check that we have a cluster when everything is done. Now, this is a pretty weak test, but I'm living with it. An empty list of tunes. Oh, we got one tune that has no notes. Okay. That's pretty boring and not much to cluster on, but it's enough to prove that we are putting something in there. I don't know. I definitely feel better with a better example, but we took that and said, okay, if you're giving an input that's a packet, contains a list of tunes, then you should create a proximity matrix with tune distance being the determinant of how far apart they are, and the input should come from the tunes in the input packet. And once you've got that matrix, you can then create the cluster, which kind of is the only way. It's the only way you would use in production to create a cluster. Okay, and we made it nullable. And now it's no longer null because it's been there, and we return the input. So in pipeline terms, we have sources and transforms and sinks. Okay, the cluster stage is designed to be a transform. So you feed tunes in coming from a source, it comes into the transform stage, and as a side effect, the actual return is just input. So it's a null transformation, an empty transformation. Identity transformation, maybe, that just takes the input and returns it. But as a side effect, it sets up the cluster. And the cluster is the thing that our dendogram uses, and then in there you can select things. Okay, now what we haven't done, we just made sure this got hooked up, and that was the end of the day Friday. Test just ran right before I turned on the mic here. But we haven't actually run the app with this in place. Okay, now I'm going to just start with cluster. I'm not even sure this works. Okay, yeah. We've got an empty list. It blows up. Okay, so that's one thing we know. All right, let's make stage now selected elements. Well, we're not that far. Empty tune list blows up the cluster algorithm. Okay. I think it's really probably makes sense to just be a guard clause, and that's that. But all right, and so I'm going to run again. This time we'll just give it our small data set, which is Miss ABC. I think it's 3 tunes, 4, 5. Okay, 1, 2, 3, 4, 5. This is getting its parsons code. Let's put the cluster in. Okay. And now the cluster, this 1, 2, 7, 8, 10, that's just made up numbers. It's nothing to do with the code down here. This was the hard-coded numbers we used to define our clustering, to define our dendogram algorithm. We created this and said, okay, here's 2 numbers very close. Here's 2 numbers very close. Here's 2 numbers very close. These are closer to this, so that forms a cluster, and then the overall thing forms a cluster. But this has nothing to do with our input. Okay. It just says we created the cluster. It wasn't null. We didn't crash. And it went on to display what it always displays. All right. Now, and this one's a little more nerve-wracking. This is our list of 40 tunes. Okay. I'm going to turn this out and then back in. Okay, yeah, I have my suspicion that there's a performance issue. All right, and it comes through. Okay, well, that's not so terrible for 40 tunes. I think, 40 is a fair bit as these things go. You might find some that are a couple hundred, but you won't find, I don't think you'll find ones that are 1,000. Okay, I guess if you're clustering different tunes, but usually this is for variations of a single tune. All right, but again, we got the same output. Now, here we've got 39 versions of Noskalan. We have held by the cluster, a clustering of 39 versions of Noskalan, I hope. And the cluster view is just these numbers, hard-coded numbers we've always had. Okay, so let's tackle this. Okay, I guess cluster the tune's not a hard-coded tree. That's kind of the next thing. All right, I'm going to get this tune list one out of the way because I think that's going to be easy. But let's see, we crashed in proximity matrix. Okay, right away, when we're trying to do clustered, if the matrix is empty, well, it's interesting. This doesn't really know how to accommodate that, does it? Well, I guess I see a couple ways out. One is you make this return value nullable down here. Clustered could return null if there is no cluster. Or we could make cluster explicitly say, like, I know what it means to have nothing in there. Okay, so I don't know the right way out. Now, in our usage over here, cluster view, no, cluster stage. We made this nullable because we wanted to start out nil when there was no such cluster. But I kind of think it would be nice to maybe say there's a cluster that has no elements, just explicitly an empty cluster. It's going to break stuff left and right. Not break, but anybody who's got a switch statement or anything like that on these things, like this one here and this one here, it's going to return stuff. Now, I don't know, level elements can be empty. That's fine. Leaves can be empty. Sequence number doesn't really make sense for an empty one. Yeah. Well, in these cases, I don't think that will come up. Better to not return an empty array instead of null. Yeah, I don't know. If I say this is an empty cluster and so it has no leaves, that seems like a reasonable declaration to me. The only one is this, the top view. Where's priority matrix again? Proximity matrix. This one, like, I think what we're saying is there's an input that has no elements. And are we going to produce an empty cluster, or are we going to return a null and have to check the null? In some ways, usually it's easier for things if there's always a value, because then you don't have to do these null checks and stuff like that. Okay, so, well, it's a challenge. So our flow is there's an empty list coming in when clustered runs, right? There's going to have to be a guard clause here that says either return nil, make this optional and return nil, or make it, give it a standard empty cluster and do that. I'm willing to go with nil for now. Okay, so if I do this optional, then there are going to be places that are asking for clustered. There aren't very many places calling clustered, so let's just build. I don't normally like null checks too much, though. I mean, I definitely react against them, but I also don't want clusters being built from empty clusters and stuff. That doesn't make sense. I don't think we would do that. Really? Okay, it's running. Oh, okay. Well, okay. So that took us where we are, but now I certainly want a test for this null case. What was the thing the other day? This one? Yeah. Okay. So that's Control Command arrow rotates between file, interface, and test. What if I did up? No, it always rotates between the three. Okay. That's okay. All right. So proximity matrix adds cluster. Oh, no, that didn't complain on the build. Okay. I'm going to say our test knows that it's got a cluster. Okay, but before the first one of those, all right. Empty, no element clustering returns nil. Choose 3 and empty. Okay, and I think this will still blow up. Since we haven't put that guard clause in yet, so. All right. 15 matrix for proximity.clustered returns nil. All right. And that should, that initial failing thing we had, I'm not sure why he's behind, but where we just selected cluster right away and it blew up, it no longer blows up. Okay, so good on you. All right. Now, the more complicated issue, let's see, empty tune list. It's not blows up is not our goal. Okay, so cluster the tunes. All right, so I don't think we need to look at this anymore, or this. Cluster's probably interesting. Cluster view, Dendogram view, cluster stage. Okay, so I guess when they call transform, as a side effect, this should leave this cluster up here. And then what's the view do? Let's try cluster view. Okay, well, we know we have this. Let's make some more room. And I don't need that on either. Okay, so here we're creating cluster as state owned by this. And then if cluster's not nil, Dendogram view does that. Well, that's okay. So I think we should be asking stage for its cluster. Dendogram view. Well, and see, we want to get this down into tune. Okay, here's stage. We know cluster stage will have a cluster if it has any tunes at all. And then this, well, let's go see this thing. Dendogram view, it's got a cluster. So I think, let's find cluster stage. It's owning this. I think this really needs to be, I think we want this to be an observable object. If the cluster changes, we want Dendogram view to change. Okay. So let me go back to filter stage. No, cluster view. Okay, if cluster not equal null. Okay, I want this to be stage.cluster. He's observed. Okay, so we're saying this one owns it. Okay, I can find my cheat sheet. All right, so where am I going? Well, let's put it over here. I put all these cheat sheet views, value on by view, binding, observable object. Okay, so we've got we're saying it's an observed object. So it must have implemented observable object, and then we provide a published field in it. Okay, so cluster stage, we should find that it's an observable object. Okay, and I imagine that's going to be an apparent thing. Right, so all stages are observable, and we now have a field we'd like to observe, cluster stage. We would like this to be observable object. So the stage is observable. We want to say this is a published field. Okay, and Yeah, like the analogy to that. So anything that does anything is going to trigger a behavior. So assigning it down here will change that cluster value, and the listeners will update accordingly. We need to import Swift UI or Foundation. Okay. All right. So that should be kind of a null change. I mean, no one's deeply looking at this. Okay. All that happens right now is it gets set here. Nobody even looks at it. Okay. So our cluster view, notice, is looking at cluster, which is a field it owns. Okay. But we're going to shift it over. Okay. And I think we're going to say, let's talk about stage.cluster now. Okay, so if stage cluster is not nil, then we should show something. Okay. Well, let's see if that's... I don't know if that can change any behavior for us, though. I don't think it will yet. Let's open our file, ABC. Okay, I mean, it's showing the Dendogram view and the cluster is not null. Okay. I thought we had these colors back to the green. I'll have to look at that at some point too. It's kind of, I'm not caring too much, but cluster should use green foreground. Okay. But the real thing is cluster view now is looking at stage.cluster. Okay. Well, that actually makes more sense. I don't have a closed file, so I had to restart. But when we first opened it, had no Dendogram view at all. Okay, so I guess that was a change, right? Make sure I saw that right. Okay, so before, when we did this, we got an empty, our standard numeric tree. Now we only get that once there's a file with tunes in it. Okay, so progress. All right, now Dendogram view and cluster. I don't think we want cluster here. I think we want tune. Actually, I think if we take cluster out of this, it shouldn't need this anymore. Okay, so Dendogram view. Right next door. Okay. So Dendogram view takes a cluster, assigns it. But we're now saying this, it should get that cluster from the stage. And cluster stage, I'm hoping it's a tune, right? Yeah. Okay, so let's go back here. And now cluster element. I'm saying this cluster will be a tune cluster. Okay. Now, optional type cluster tune must be unwrapped. Okay, I guess this is an optional cluster. Right. Okay. Oh boy. I may want to back up. I really like to do this with minimal disruption. Okay, so Dendogram view. What's my claim? My claim is this is redundant, that it should be getting the cluster from the stage. All right, but let's revert and do it a little more cleanly. All right, I think it's just these three. Anybody else? I don't think we touched any tests. Okay. I don't like that red there, but okay. All right, so Dendogram view. Okay, I'm saying it takes a cluster now. It doesn't need to. Okay, so let's pull this from view. I don't know. I'm passing this thing. Didn't we have it in Dendogram view to start with? I can't remember. All right, we're going to put it there and get rid of it though. Okay, so I'm saying, well, let's put it down here. It's going to get deleted at some point. Let's call it int cluster. Is this stuff? Okay, so rather than passing it in, I'm going to say self.stage equals, I want to say int cluster. For a moment. Now that's going to make this thing, yeah, it doesn't. Okay, optional type int must be unwrapped. Why is int cluster? Why is it optional? Cannot assign value of cluster int to cluster element. Value of optional type cluster event. No, I don't think that's relevant. I think this is the part that we care about. Okay, so cluster. Now, here, I'm going to say type alias element equals int for now, which means this comes out. Okay. By optional type int cluster. Oh, I don't want state. Oh, I made him optional. Okay, let's do that. Okay. Now, I think this file's okay, but the people who called Dendogram view are expecting to pass a type, and we're still passing. Oh, and they're passing a cluster, so we're going to take those out. Okay, so Dendogram view. This should complain here. Cannot specialize non-generic type, right? And then cluster goes away. Okay. Now, tests, I think there should be some tests that break because of this too. Not run poorly, but nobody's complaining about that. Oh, we didn't test Dendogram view per se. Okay, we aren't testing views. Okay. I traded some notes with John Reed the other day, and he mentioned View Inspector has really improved. So I think I'll maybe do a little side project and try View Inspector and see how that works and see if it's worth pulling back into here. All right, so this builds, and it should run as well, and it should run the same. We're still passing this cluster view. Okay, now it's no longer nil because it's the cluster view here. All right, but I think we made some progress. Make Dendogram view non-generic and no longer pass in a cluster. Yeah, yeah. I think, well, my normal strategy is to try and keep as much computation out of the views as possible, other than like this kind of thing, you know, where it's computing on the views stuff. I tend not to worry too much, but I don't know. There's definitely more here that I'm totally happy with, and this stuff is downright drawing lines, and that's, you know, to some extent, I think if the cluster is right, it's right. But we definitely screwed some stuff up the other day, so that's not correct. Okay. All right. So now let's see where we are. So now cluster view, it still owns a cluster. We don't want it to. We want it to ask stage.cluster. Are you nil? Okay. And stage.cluster. Okay. So cluster has this. Notice it's not published yet, so it's not going to update anything. So I think, well, I think this will always be nil. I don't think opening the pipeline will make it non-nil. So it's nil here. ABC again. Okay. It's got the value now. Okay. Well, okay. I don't know that that's, well, in a sense, it's not wrong. We want it to display when there's a cluster, so I guess I'm glad it did. What's surprising to me is that the field not being published and it still got updated, but we kind of don't control some of that. Transform got called, cluster got set, and somebody noticed that. I think we do want to make this published, and I don't think that'll hurt us. Oh, went through that already. Import foundation. Okay, empty, open a file, get a view. Okay, no change. All right, so we're making cluster view show Dendogram if stages cluster is not nil. Okay, now cluster view, this variable should be unused. Okay, so let's take this out. Okay, so, well, that's definitely cleaner. Okay, that's the kind of view I don't feel that much need to test. Okay. Dendogram view. Now this, okay, we got cluster element. I don't want elements though. What I want is, I want self.cluster equals stage cluster. Okay, and then this, that should be an optional problem, right? Cluster tune to dendogram view.element, which is cluster int. So it's working that out so far. If this is tune, I still should have a complaint about. Oh, there we go. Yeah, optional. Okay. This should be optional according to that. Now, what's that going to mess up? State, yeah, we can't. Cluster.leaves.count. So, okay. Well, this is my first indication of having to deal with null in this. Yeah, let's deal with it. If now, I think, can I do it this way? That if available, otherwise. Oh, maybe I just do this. If cluster not equal nil, then set up that initial claim. Yes. Yeah. Sorry, I missed that comment, but yes. Okay. If cluster not equal nil, that should take care of that. Well, okay. Then it's no, not nil. All right. Now what about down here? Cluster. I hate to put this dependency in. We know Dendogram view is not called unless the cluster is non-empty. So this theoretically is okay. I don't necessarily like it. There's some more. Okay. This is, yeah. Right. Okay. That should be fine. Now, what do we got up top? Okay, so element is now tune, cluster element. This is no longer used. Okay. We'll delete that in a moment. I guess I want to... sorry. Yeah, if it was an empty array, it would render nothing. Yeah, that's the thing though. I'm saying cluster.leave. So if I had made my cluster that, I'm an empty cluster kind of thing, I could have said his leaves was empty, and then all this would not be called. No contents. Yeah, cluster.connectors.build would just return empty and all that. So it gives us a place to look later. But I think at this point, I think I've got it hooked up. So it's looking at cluster.stage tunes. Yeah, I don't mind the laziness, but like I hate going through and having to argue my way like, oh, I promise I will never call this with an empty cluster because the parent view makes sure it doesn't, it's like, yeah, you're asking for trouble. If somebody's going to take Dendogram view someday, make it a top level view and then blow up. Okay. And, given I'm the only programmer, I know who that somebody's going to be. All right. But I think I may have hooked up tunes at this point. Let's see if that's true. And if it is, we'll unwind and clean out. Okay. There's a way to turn this off or shut it up. What is that? Clear all issues. Yeah. Okay. All right. So now if I try a cluster with no file open, we don't get a cluster field shown. All right. Now I should get a cluster of 5 things. Hey, okay. It's got problems, but they are the problems of realistic data. Okay, this name is not so great either, but it is tune stuff. Okay, now let's try that other file that's slow. And I don't know, I don't know where my phone is. Okay, not bad. Okay, it's crowded because tunes are more similar than they looked. But I don't know, can we do something with this? So here are two tunes that are basically identical, another two that are identical. Three branches are the same. I'm not sure I'm following you or more. Well, yeah, these things are colliding. I don't know. The trouble. Well, okay. What are we gonna do? One thing would be we could say everybody gets a fixed distance boost. That just happens to be big enough that one diamond's worth of boost, and then we have to adjust the overall size and all that stuff. Not unreasonable. It would, like these two that are perfect matches. I could see having a little tiny prong coming out there, and maybe just scooting it out a little bit. I mean, I don't know. All right. So anyway, I mean, this is a big woohoo moment for me, though. We've got something that says, things really are clustered to each other, and this subset is a lot closer than this subset. And you see pairs that are basically more or less identical. Parsons code, they might not be identical melodies, but it's revealing. I mean, they are consistent, and this one's a hair to the left. I don't know if any are totally lined up. They look like they're all separated. It's just not separated enough, which maybe should have been predictable to me. But yeah, I mean, this kind of thing, I definitely kind of expected some of this stuff to happen. That as you put more and more stuff in, you've got a lot less room to work with over here. All right. And we got the names are not very helpful. Okay, but that's good enough to criticize. What there are longer branches at level 2 between diamonds. Well, these ones are basically identical. I mean, they might have a tiny difference, but a longer branch at level 2 between the first and second diamonds. Are you talking about these two? Now the best matches are ending up on the bottom, and we did some stuff to flip them, so maybe that cost us. Yeah, so these two, the longer branch at level 2, yeah, it should always be longer than the thing it's pointing to. Let's see, where's it going? It's going to this one. Okay, so all the others. Okay, so that's the top one or second one plus all the others. Okay. Very, very cramped. Oh, up here between these two lines. Yeah, I think that's really a consequence of like you're working. I mean, we're finding the closest matches, and then the next match is pretty darn similar, and so what happens is this one's moderately far from this one because the gap's longer, I guess, but the next one is pretty close to that. So the the thing is, if these two were more similar to each other than this, the third from the bottom is to the two bottom ones, they would have clustered together themselves like these two did. But the bottom two are the most close. Then this one is close-ish, but closer to these than it is to this one. So this one gets this level, but then these two, they sort of just missed, it's like, well, it's pretty close to the three of them now. And so it's just not that far distance. And if the diamonds weren't there, I don't know, the lines would not, well, they would be like this, I guess. Yeah, they're just sort of arbitrarily close. They are different though, because every diamond, like all these, are slightly to the right of each other. I can't tell about these two. They, yeah, I can't judge that. I think it is slightly though. You can see them staggered up here. They can be the same, but they're always going to the right. So I think it really is, yeah, like this situation. If we had said every line horizontally is going to be at least far enough away that the tip of the diamond doesn't touch the line, right? That would spread this out by, I don't know, probably a diamond width per line, and so it would be quite a bit wider. It would be less mathematically accurate, but it would look a lot better visually and, be a lot more manipulable. All right. Horizontal distributions are uneven. Yeah, I don't think they necessarily have to be even to each other. Excuse me. This one, like, there's nothing exactly the same level as that one. That's definitely inside. These are all further left. But I think, well, the fact that this one, I feel like somewhere we put a reversed in to get them in the order that we had them. I almost feel like maybe that's hurting us in this view with realistic data. Okay. But anyway, I think the two takeaways I have, one is the names on the left, that's just some generic two-string, default string kind of thing. We wanted the actual, probably the same as this, the tune number and the title, even though these numbers, neither of those is guaranteed unique, but it gives you something to go by. Yeah, so two things. One is the name. The second is reduced crowding of the view. Okay. Okay, let's see here. Well, I think we've done that. Show a useful name for the tunes. And spread out horizontally so there's less overlap. Okay, but this we did. So, big moment. Now, unfortunately, you can't select them. Well, you can select all you like. That cluster is sitting there for selecting purposes, but nothing downstream actually reflects it, okay? Because what my intent is, if you select this box, these three tunes should be the only ones in the list down here that it should filter. That's the purpose of the diamonds in the first place. Okay, let's see. So cluster the tunes, and that's definitely kind of a woohoo moment for us. All right. Let's check that in. Okay, now I'm going to pause that we want the useful name, but I want to pause and just kind of walk through the pieces a little bit. So we still had this notion of, might it be better to would it be better to have an explicit empty cluster? Okay, that's a question. All right. This thing I like a lot better. It's saying I have the controls for this thing, which don't amount to much. And I have, if the stages cluster is set, then I'll show the dendogram view, because you can't have a view like that without a dendogram. All right. And all right, let me find, okay, I'll just keep going. All right, so this is our dendogram view. My goodness, it's complicated, but let's clean this out. Nobody should be using that. This element tune thing, not needed. Selected set event, that's correct. Control tune. Okay. And that's good. Cluster tests, cluster stage. All right. You have a published field, the cluster. You've set it when somebody pumps through some packet data. Good. Tunes, I'm going to ignore. Definitely ignore that. Try and get this down to something I can look at. TuneSim app, I don't think I need that. All right, let's run tests. Boy, he can't get over that. Okay, let's do okay, test should run. All we do is fix blank line. That wasn't even there. Boy, you're persistent. Okay. I don't know what to do with that. All right, I reset everything, so. Okay, so clean up Dendogram view. We did code. Okay. Okay, Dendogram view. We displayed, okay, we got the cluster. We should have the elements somewhere. Well, I guess these are the elements. Nope, that's a cluster. These are the elements. Oh, we did have reversed in here, and I took it out at some point. Interesting. Okay. Oh, have I done something funny? Those two need to be coordinated as far as reversed or not. Okay. I think we're going to see something's funny going on. Let's see if we can tell with the small data set. I don't want to go through the big one. All right, cluster, and let's look at ABC. Okay. This, well, maybe we need the names just to make sense of it. The connectors, I got a feeling that, yeah, something's off. Okay, because these two are bolded because those elements are selected. Now, that looks all right. That looks all right. That one's okay. So this... Well, Old Joe Clark and Old Joe Clark 2 should be very similar, 4 and 5. Okay, we're going to have to put the names in, but call me skeptical that the leaves should be in the opposite order of the content, the connectors. I just don't believe it. Okay. Let's deal with the name then. All right, so here's the clusters text string describing leaf.element sub 0. Okay, so let's go see that thing. Well, it's a cluster of tune. This should be calling tunes string method, just if it has one. It has a custom debug. Right. Okay, I suspect it's calling that. Yeah, why wasn't the last cluster selected? I think it's something about, well, I can think of two things that could be wrong. One is the view. So the big thing to me is the elements are coming out in the order the cluster lists the leaves. The connectors are coming out in the order the cluster lists them, but then reversed. So I think it's selecting the wrong. I think the diagram part is upside down from what it should be. But we also had that initial selection. Let's find that. That's in here, right? Elected elements. Okay, 1, 2. I'm also not sure if we're numbering things from 1. We did in our test, but I think, yeah, I think 1, 2 is probably wrong. Let's run that again. Okay, so file is ABC. Here's the cluster. Yeah, I definitely had thought we changed it to 0 indexed. So I think I'm off on two things. I think this is selecting node 1 and node 2 and not selecting the child nodes. So that's wrong from that sense, that we wanted the we really want 0, 1, 2 in there. Actually, no, 0, 1 and the rest of it. Okay. And we're doing that in the view. So like there's an example, right, of something that's in the view, but not really, I don't know. It's not really the view's job to know this. Okay, so let me run this. I think it's going to give us this 2 on the bottom with their parent. But I also suspect that's wrong. I think we have 2 errors going on. Lucky us. Okay. Yeah, so I think this is 0, this is 1, and this, which should be these 2, and this is 2. Okay, so I think we fixed one thing. Okay, so initial selection should select rows 0 and 1 and their parent. Okay. Now this count plus 1. That's probably okay. I don't know. Boy, I'm going to have a lot of errors in this line if it's not. Count plus 1. So I have 0, 1, 2, 3, 4. The count is 5. I think that it should be node 5, actually. Because, yeah, we fixed a bunch of tests around that. Okay. Yeah, it should be this node. It's selecting 1 higher. Okay, let's fix that too. That's part of making it 0-based, I guess. Okay. So I think this is correct as far as it goes. This is element 0, element 1, 0, 1, 2, 3, 4, and then 5 is the most tightly clustered, which really is these two, because we reversed it vertically. I don't know if that may have been seeming okay because of our test data or something, or maybe it was just there. So I think it's the reverse call in the sense that if I take this out, I think it's going to look better. Let's try that. Okay, so I believe this will make the connectors connecting to the right place. No. Well, I think my alternative was to make it reverse both. But this did not matter. So what am I doing wrong here? Okay, let's try this reversed. If I can. I don't think it's an improvement, mind you, but at least it would be consistent. Excuse me. Not mattering here either. Okay. This doesn't matter. Well, okay. In a way, I don't think this matters because the Z stack says it doesn't, they're all being written over top of each other. It just means this one is on top. Oh, that's why we did it. Right. We were making sure to draw things from leaf to root, the root's on the right, so that when the next level came in, it would write its node over top of it and get rid of that line that was cutting through the node. But the actual order here doesn't matter, but somehow we've got the disconnect between, I've got these running 0 to n down and these running 0 to n up. So something's funny. All right. I think we're due for a break. Let's take a 3 or 4 minute break and come back and figure out what's going on with this. But it's definitely something about maybe we're not writing our, I don't know, maybe the contents is wrong. I don't think reversed is going to matter to that. So we'll see. All right. Take a few minutes and see you then. Welcome back. All right. Let's see. how can we see? All right, I want to see the difference of this with reversed or not reversed. I think we can see the difference. I think reversed, let's see, I don't know which one we're running now. I think reversed is going to prevent that line from hitting the triangle maybe somehow. Cluster. Okay, so the one we were preventing was the line coming in at the top of the cluster, but like something's weird here, right? Unless there's a diamond totally hidden under here. Got that one, 3, 4. Shouldn't the parent line be coming into the diamond? Okay, I'm going to take off the reversed. Okay, oh. This one points in there. I don't know if the parent has to come in at the diamond. Okay. Something is screwy. This works. I would have thought. Okay, I think it's going to be easier to understand if the names actually come out as names. Let's put something in to do that at least, and see if we can make more sense out of this. So, well, let's make extension string. Custom string convertible. A description of string, and then what are we returning? Well, the thing we know they have to have an index and they have to have a title. All right. That gives us that value. So if we return self sub, no, what's the name? ID. And where are those names? Metadata something. Is it metadata? There we go. Yeah, title and ID with a capital D. Okay. Wait, what just happened? Oh, these two. Yeah, so Air 7th and Nusky, let's see what they look like. Right? They don't look like anything. No scaling is this nice mountain range, and Air 7 is like this long, tall mountain. Okay, there's no way those two are closest when, look at these two. I mean, this one's 3 or 4 notes longer, but up until then, it looks like they were the same. Okay, so that tells me that this is telling the truth and this is wrong. Okay. Now, I don't know. All right, I'm going to pull the big one in just to see what that's like. Why do the top two elements get... Well, I thought we were putting the sequence numbers in that list. Let me ring that up. Dendogram view, was it? Owns the selection, which seems okay. Okay. 0, 1, selected elements. Let's make sure that should be treated as a sequence number, not as a index, right? So, okay. So for each cluster leaf element, we got the name of it. It's asking for sequence number. I'm honestly more puzzled. Well, we can probably put we've got the number. Let's put the number in here too. I'll put it in brackets. Number. Need to add the numbers to the first column. Well, let's undo that. Done something poorly here. Okay, string describing that. All right, I'm putting the number. Okay, so that should be the number, the row number. So that should go 0, 1, 2, 3, 4, 5. All right, let's run that. Yeah, 0, 1, 2, 3, 4. Okay, so its initial selection is 0, 1, and 5, because 5 is the count of the leaves and is also the first node. The first parent is always the two most similar plus the node connecting them. Okay, so if this diagram were flipped vertically, it would look fine. So I think I don't know. So yeah, so I'm going back to this comment. Perhaps the Y position is subtracted. That sounds more like it, that we've done something there. So flipping the names would work. Well, I would have thought so. We got the elements. Let me reverse the elements. Maybe I'll put it before the enumerated. But I thought we had both set at one point and it did not work. So my hope would be this would put the two most similar at the bottom and properly bolded. Okay. Now, but I don't believe it, right? No scale in an air seventh. Well, down, 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 up, up, down. That is not, there's no way these two are more similar. It should be the two Joe Clark's ones. Right. Something's weird. I mean, it really is the diagram that's wrong here. Although, I don't know. I had thought I was putting the two most similar items at the top of the list and going down from there. So what I think this has done, it put the right two... Well... No, something's funny. All right, let me take this out again. If I click this, it's that initial bolding that just seems wrong. That looks right to me. Like once I get it set, it does the right thing. And these two, like, do the two old Joe Clarks look the most similar? They sure do to me. One's a hair longer. Rewoon, whatever that is the next. It's kind of somewhat-ish similar. This one goes down more. But if you had to say, was this closer to this or that, I guess you'd say this one really tends to go up and this one tends to go down, and so does this one. And this one goes up, up, up. All right. And then where's it put Noscalon? I would say Noscalon is closer to Old Joe Clark than this other thing is. It would be very hard for a short song to be marked as very similar to a long song. So that does make sense to me. So it's something about that initial selection is screwing it up. But why this is 3 and 4? It sure does. I mean, I'm bolding based on selected elements contains leaf's sequence number. So oh, can we see anything there that would... The Y scale. I don't know. Okay, let's go back to the top. Okay, selected element starts out empty. And then, assuming there's a cluster, the initialization of this view selects those elements. 0, 1, and leaves.count. Scale font, inner frame width. Okay. I don't think we have a complaint about the lines. They don't know what they're drawing. They just are given a connector, which was one of our design things. Well, I could... Yeah, I mean, the reason I'm doing this is I think this selection paradigm is a new paradigm. And so I'm trying to, if it comes in like this, nothing tells you to click the diamonds. Okay. But I think if it comes in like this, wherever the right two are, I think seeing the bold lines here with the diamond selected tells you, yeah, if I click a diamond, I'm going to get a bold line, for these other things. And the first time you see it, I think that will make it trigger. If I select nothing, let's do that. I mean, I think it'll work better, but I don't think it'll be better. But that was definitely a decision I was making from a kind of UI point of view. Oops. Yeah, so nothing here tells me to select it either. The cluster knows the elements. Yeah, so the leaves are the elements, and the cluster knows the leaves. Let's get cluster back. We haven't looked at that in a while. All right, so basically each element starts out as a leaf, and then clusters form from other clusters. So they could either be clustering an element, or a cluster and an element, or two clusters, or whatever. That part feels okay to me. And I think the view is not wrong, right? This should click, and these should all click and be where they should be. Can I click the cluster diamond? Like this one, or all right. So I can leave that off for now. In a way, this is well, that thing I was doing from a user interface perspective, I wanted this stuff selected initially. I feel like I know how to get it, but somehow these two are being selected. I don't know if I can get there. Let's, instead of the 0, 1, 2, let's put the sequence number. Do we have that? Yeah, it's a cluster. Leaf dot elements. Leaf is a cluster. Elements. Okay, of an element item, its element is itself. Okay. So, sorry, Dendogram view. Okay, so leaf dot element sub 0 is the leaf. I guess we know these are leaves. We have a better answer for this. Those are tunes. I don't think that's a better answer. Okay. Sorry. Can you click it? Yeah. I mean, I don't know if I can or not. I don't know if I can at the initializer or not. I should say it that way. But I mean, I feel like there's some big hole in my model, my mental model of this thing. If 0, 1 and the first leaf are not the sequence numbers of the correct elements, that just seems like a big misunderstanding in my part of what's going on. So now you could imagine something that, like, once it opens the first time, it clicks on that, vroom, goes over and clicks it, and then we see everything highlight, and that would tell you, like, hey, you can click this stuff. But I was kind of hoping to avoid that complexity. Selected elements contains connector ID. Okay, that's all right. Let's see, back to here. So leaf.elements sub 0 is a tune. String describing tune. Leaf is a cluster. Okay, so leaf dot, is it sequence number? All right, let's try that. Okay. 1, 0. This is making me feel like I don't understand my algorithm as well as I thought I did. The order should be... Okay. So the original list coming in came in order 1, 2, 3, 4, 5. We assigned their sequence numbers as they came in. So this is correct, I guess. It looked funny, but 3 and 4. So that tells me I'm completely wrong, right? It should be the last two sequence numbers. Given the, well, no. We should find that most similar cluster. I don't know. Maybe this is just, yeah, the sequence numbers are, I guess I was thinking the sequence numbers were, we were pulling those elements in as they got found to be the most similar. And so I thought 0 would be old Joe Clark and 1 would be old Joe Clark 2. These two, Joe Clark and Joe Clark 2, they're very close. Joe Clark 2 has 3 or 4 or 5 extra notes on the bottom, but otherwise I think they're identical. If not, they're very, very close. So they are the right 2. But I think what's going on is the list of tunes is number 1, number 2, number 3, number 4, number 5 by the ID. Okay. So number 1 goes into slot 0, element sequence number 0. Number 2 goes into the next one, which is 1, number 3, number 4, number 5. And in effect, it's, X minus 1 for each of these. Then then the algorithm runs and it's trying to find the most similar pair, which is these two. And so this initial selection should be 3, 4, this. But those numbers are arbitrary, right? Because it could have been, let's say, 3 and 4 swap positions here. If old Joe Clark was number 3 and Rewan was number 4, then this would be 2 and 5 together. So that simplistic algorithm of 0, 1 is not going to work, given that these numbers are assigned as they come in. And I think this is definitely a gap in my understanding of the algorithm, because I was thinking the elements would be assigned by picking the most similar to. Let's see, go back to the algorithm. The clusterings are assigned 0, 1 to n minus 1. Okay. Disjoint clustering, L0 is 0. Sequence number M is 0. Yeah, I mean, I think I'm just totally off base on the initial selection. Okay, can you read the initial? Yeah, I mean, it's not so much I don't think the element list tells me, because the order of these, I believe, now this may be me misunderstanding even more, but I believe that because we have these from the bottom up, I was hoping for them top down, and I thought we were getting it top down. So I've got more than one confusion going on. But my belief was the bottom 2 elements, which I thought would be the top 2, are the most similar elements, and therefore they get clustered together and show up first. And then you add in the next most closest one, Rewoon, And then you add in the next most closest, no scalon, and you add in the next closest, air seventh. And so the top one is sort of the furthest element away from not only the bottom cluster, but all the rest of them. Okay. So it's the worst match for any of them. So I would, what's going on? So I think the clustering is okay given this order. I think the clustering is okay. The two most common, the next one, yeah. This all seems okay. Okay, so I'm going to put a to-do that says fix initial selection to get most similar elements. To get two most similar elements. Okay, that's a thing I want. All right, now is the set of things really finding the most similar stuff? I think this is okay. It's also backwards. So let me put the most similar two elements on top, least on the bottom. Some sort of flip I want. Okay, but I'm not complaining. I mean, this picture to me is a good picture. I know these two are pretty similar, and we go from there. All right, I'm going to load this other data set now, the big one. Okay, and this takes 10 seconds or so. Kind of slow, but okay. So now I think, oh, something's wrong. Why is anything selected, right? But I think these two are the most similar of any. Number 1 and number 39. Right now they're in a sorted order. Okay, those look identical to me. I can buy that. I think it's random. Like these two look identical too. 32, 35. Let's see them. 32, 35. They are also very close. Now, let's look at 32 versus 1. Here's 1. 32, 35. They're similar to 1. They're not bad, but this one's longer, so these would have trouble being a tighter match. Okay, I mean, that's encouraging. Why anything started out selected, though, is beyond me. All right, where else we got something similar? 28, 29. Here they are. Okay, they're very short and also look identical. Okay, so these ones with the bar, right on the left edge, their distance is 0. They're basically the same tune. What the heck was going on with that initial selection? Okay, let's find clusters down here. Okay, so here's 33, 22, 139. 33, 33. Well, it's longer. Where's my 1 and 39? This order is not helping me. It's trying to do something, but it doesn't really work that well. Oh, here's 22. Okay. 22, it goes up a little, up a little, up a lot, and up a little. Okay. 22, up a little, up a little, up a lot, up a little. Yeah, so even though the distances are a little far apart, I think if you laid this one, number 1, over number 22, you would see see, the gaps aren't that big. Okay. So I would say that's a plausible next answer. If I get the elements from the cluster. Well, it does matter because, oh, I see what you're saying. I think that right now, rather than just getting the list of them, well, they do come from the cluster. I'm asking for the cluster's leaves, and that's coming out in the order of the cluster nodes. So theoretically, if you started at the root of the cluster, which is on the right for us, and you worked your way down to the most, you all the way to the left, kind of following the more closely connected ones, you should get those leaves in that order. That's a confusing thing, though. You're right. It's kind of okay. So let's see. What do I believe? I think. I mean, just from a quick glance of things, but like these two are obviously identical, so they belong together. The next one's pretty close. The next one's fairly close. These two are identical, but they're different from this, and they're close, and they're more identical to this than the others. All right. And actually, interestingly, like notice which ones are called Noscalan. These two are close to each other, but they end up pretty far from the rest of it. But all these other ones, none of them are called Noscalan, only until you get down there. So we basically, in this sense of the titles reflecting the same as the song, then it strikes me that all these Noscalans are very close to each other, and they have the most similar titles, other than this one pair that gets stuck up here, and that's kind of okay. It's just sort of a good sign. Now, okay. So, I don't know what to fix first. I feel like this seems mostly okay. This is suspicious, isn't it? Okay, I'm a little confused on our drawing, I guess. My feeling was what we were trying to do, I think, was we were putting the diamond in the middle of the space, and we were putting the connector connecting to the middle of the space, and so it should be touching the diamond. Now, I may have put a gap somewhere. This one, I think, the white or empty space around this, it's actually kind of sandy colored, I think is why this line looks goofy, that the diamond is actually infringing on it. Could I fetch the elements from the cluster? It shouldn't matter how you flip the Dendogram. Is that true? Well, okay, let's see this reverse thing. What's going on? Okay, I think there's another issue. Let's see if I can get it right. Let's see this. Oh, this line is connecting. Wait a minute. I think 33 and 22 are very similar, and that's part of it, that these this line, oh, I think this line is probably drawing to the center, but it's covered up by the space here. Okay, let me take the reversed off this thing. Maybe I picked the wrong approach to those diamonds overlapping each other. Maybe I should have just built in the extra space. Oops. So I'm expecting to be less confused about the way the lines are going. And I am not, in fact, less confused. Well, this is going to the center of the cluster. That's fine. I would have thought the diamond is in the center of the cluster. This line should be connected to the diamond. If it's going to the next thing. So, where's that roller? Okay, that leftmost selected line is 1 1/8 inches. So half that should be 1/4 plus a 16th, 5/16. I would kind of say that seems to be, but this line to me is not hitting halfway down this line. And this one is not hitting halfway down that one. All these, well, isn't this weird? Okay. That's hitting the center. That is clearly not. I thought it did. My intent was that it would, like this, and that's why we did the reverse, so that this one draws first and overwrites. Though the shape has a background, a sandy colored background, it would overwrite this little bar sticking in. But lots of these others, well, that seems right. This one does not. Like that little, well, is that, it's hard to tell where it connects. Yeah, they're in the center of their vertical line, but I thought we were drawing the connector to the center of the vertical line, the vertical line of that group, of that cluster. Like this one's right and this one's wrong to me. Is there anybody who's right at the second level? I don't see anybody. It is very hard to tell. That's a first level. Oh, man. Okay, so the connectors, let's see, where's this one going? There. That's a first level. That one. Yeah, I absolutely believe this line should be here, not down here. He's not the center of anything as far as I can tell. Well, maybe he's the center of the page. Diamonds are not the center of the group, center of the vertical. Yes. Okay. Oh, man. I think, what should we fix? I guess I really want to understand these connector lines where they're not centered. And I also don't know if the overlap is making it worse. That one looks centered. No, this is his parent, though. Okay. It may be that my testing was not good enough to detect, to worry about multiple levels. And I thought if I had it right here, it would kind of recursively fall out. But this is way too complicated to look at for that. Can we see it? Let's see. Go back to our other tune. Why did it not have this problem? Or did it? It did. Okay. That's a set we can work with. This node. Okay. That one drew where I would expect, diamond in the middle vertically. It's this node that does not. Okay, what can I print that would tell me? So is this... So, okay, I think if this one is... If this line, maybe it's drawing to the center of this whole piece. That looks like it is between 3 and 4 there. 3 root 1. And so this line's connecting there, but it should be connecting to the line of its child. I think we can hopefully see that in the code. Connectors. Let's go back there. Yeah, I'll catch up with you. Okay. They don't do much. Okay. Where's connectors? That was the one that did all the work. Okay. So a cluster. Okay. So we find the center of cluster 1. Sorry, result is a list of connectors. Okay, we find connector 1, the center of cluster 1. Well, that may be the problem right there. Let's make sure what center does, but cluster is the row number plus the count. Okay, that is it. It is grabbing the vertical range, starting at row number and going to the number of elements in this cluster. So let's go back. Okay, so I've got cluster 1. Okay, this is the actual cluster. And then where's this? This branch. Okay, connector is doing the averaging, right? Let me pull this. Oh, I thought I could. There. Okay, connector. And we want connectors. Okay. Okay, so connector, is he calculating the center? Yes. Okay. Okay, connectors.center C1. Center one's a vertical. I think it's a double. Yeah. Right. So it's always adding one element at a time. So this one starts at the starting row. And this one goes to the end of the second one. Yeah, I want the connectors to connect to the center of the child's connector. I don't know if I've got it quite. Center is not involved in this, right? So here's, okay. So this builds, I think what we're doing is we're putting in, it's recursive because this is the connectors routine. So we're saying first find the connector for the child, then find the connector for the next one that we're connecting. So, so however many children the child has, the next one is basically the initial row plus that count is kind of picking up the next one. Then we do my cluster and we put that in. So once we have the two children connectors, we do that. So I'm going to extract some and then I'm going to make connector 1 and connector 2. Oh, but that's not how that works. Not the problem I thought we'd be solving today. So I think the test data we have with the numbers, I think the sizes of the things, I don't know, it didn't seem to have this problem, but okay. So all right. So the cluster is going to be a tree of clusters, and down at the bottom are the elements down at the leaf. And starting row, we come in with 0. So we're just saying start this thing from the top and go to the bottom. Now center one is connectors.center C1. Well, it's like I need the connectors. I don't know. Connectors of C1, that's getting all the connectors that resulted from cluster 1. Let's see where connectors is. Connectors. Okay, this is. I don't know. I'm not happy. Okay, so cluster sequence number. So the connectors for this is a list of these things. It's recursive because it's calling itself static function. Okay, I don't mind that. This thing, it branches from C1 C1's level to the center of 1. Okay, that's a problem. And then the length is the right length. Okay, this one branches from C2's level, but C2 level to the center 2. Why center 2? The Y is the one I don't like. Center 2 is this. Okay. But okay, yeah, we're calling connector.center. Let me find center, sorry. Okay, that's just doing the stuff you want. Here's the connector center function. Yeah, that's calling this one. And I think this is where it's off. I think it's taking the row number plus basically kind of like the count minus 1. I mean, it's kind of covering row number plus count divided by 2. So it's not getting the cluster, or it's not getting it from the connector. And that's what we need. Okay, so it connector C1. This returns you a list of connectors. That's the part I don't like. All right, so what I think should happen is you should go to C1, and I don't need the set of connectors. Well, maybe a connector needs to know its children. What does it know? It knows the ID, element IDs, that's tied to the children, level, top, bottom, center. I wonder if, would I get any advantage if connector knew its children? I mean, a connector always, well, he has his own sequence number, and these are the sequence numbers of his children, of all his descendant leaves. Center connector seems correct. I don't think this is correct because it's averaging row numbers, and that's what we are doing here. Like, this is row 1, 2, 3, 4. Here's 2.5, and that's where that's coming in. So he's pointing to the row number position, not to the diamond. Now, it seems to me that diamond could have been pushed down here if that was better, but I feel like the diamond should center the two things it's connecting, not everything. Because it doesn't know, right, it doesn't know what's, well, he does know his total range. Okay. Yeah, there's two centers, right? So that's funny. So I guess I'm saying we could have put the diamonds here being the average of all the rows it contains. But that would look funny, right? Because he contains... Let's see. He contains 0 through 4. Would that work? Not necessarily, because where's he connecting to? He's got to connect to the diamond, the previous diamond, I think. The one in row 16 does the single top bottom midpoint. 16. If you're talking about this line here, I agree. It does the midpoint between rows 1, 2, 3, 4 is 2.5, and he's right there. Oh, sorry, connector.swift. Yeah, he does the midpoint of. Yeah, you're right. That does the midpoint of the two connectors, right? Assuming their branches are right. Well, okay. I don't. This seems to be working with center 1 and center 2, which are coming from that. No, it's not. Okay. That's part of the problem. See, I think what's going on is I don't think I know my children's connector. Cuz I'm in here, I call connectors C1. I'm getting the list of all its connectors. I mean, maybe I can find the one with the highest level or something to figure it out, but we don't do that for sure. I mean, I would just like to know what's your connector. And you've got a bunch of children, that's fine. So is this the one that the diamond is drawing from? I bet it is. Let's see. The diamond seems to be in the right place. This is 2, 3, 3.5. So 2 to 3.5. That diamond seems to me in the middle of those two. Whereas this line, instead of connecting to the middle of those two, it's connecting to the average of these, which is directly on old Joe Clark. Okay. I think we're to the point of the problem now. What the solution is, I mean, if a connector knew it's got two children connect, it's either got, well, does it have two children? You could imagine an empty connector, I guess. Okay. So I think yeah, the fact that we have these two center methods and they do two different things. One of them centers based on the row number. One of them centers based on the position of the two lines. And I sure like the two lines a lot better than the row number. Something in my head must have made me think those were the same or similar enough or something, I guess, because I definitely was not worrying about this problem. Okay. But what I find weird, like if I make, okay, if I have an element, I say you have no connectors, that's fine. If I have a cluster, let's say I have a cluster of two elements, the center of C1, starting at starting row, is starting row. Because that one is, I don't know, that's adding one entry, I guess. This one is adding the center, wait, from starting row to what? Oh, to the number of elements minus 1. Oh, so starting row, okay, I think this makes sense. The starting row here is whatever the next place we're going to put things is. Then we put so many things in, so we filled up so many rows. This one has to start where that one left off. Okay. Does the diamond use the center function? I think it uses this center. But let's go find it. I think that's in here, right? Connectors. Cluster.contents. Okay, we get a list of connectors and then cluster draws them. Okay, so he draws a horizontal line, a vertical line, and then the diamond connector.center. So he is in fact calling this one. Okay. Now that says to me, I think the information is here. I'm just not positioned to get to, I would like to know, I don't really want to know what are all your connectors, although I guess I need to at some point, but I want to know for you, C1, what's your vertical position? But when I get it back, it's just one of this list of things. And so I think in effect, this one, well, let's see, where, well, center one. Yeah, I think I can say it clearly to myself. So center one is some range of elements, and it's getting the middle of those. And the reason when we just have two, it works is because that's always, the row number plus one, plus a half. And I think that's what we're seeing here. It's this row number, and the diamond goes halfway in, and this is that goes from there. So it's saying the center for diamond purposes is the first row to the last row and take the middle. Okay. And so that makes that first leftmost diamond work. Then when we get the connectors, then we go a level up. We're saying for the first child, it has a set of connectors. I think in effect, we're taking the center of the stuff in those connectors to the center of the stuff in the next connectors. And so I think that's where this diamond came, and he's actually still right, because this is always one row, and this started out two rows, but the center is exactly half a row. So this is 1.5 rows, and this is 3/4 of the way through that. So it's pointing at the top here. Okay. So the diamond is always drawn halfway through its line segment, but the line segments are not being computed correctly. They're using the other they're using the row-based calculation, I think is the way to say it. This this point right here is going to be exactly halfway through this list, which is the middle of Old Joe Clark. Carried across there. No, you can't. Sorry, where are we asking? Are you talking here? I don't think so. The starting row is, I mean, I think starting row is saying, where are you going to start placing things as you match them? And for my child, I'm going to tell my child, hey, child, if you have a match, put it in at row 0, because it initially gets called with 0. And then the next, like in 20, it's starting row offset by the count. So however many things it had in it, that's the next row we want to go to. So we got to start filling in from, the space left after C1 did its thing. So I think the starting row aspect is right. I think what's wrong is this center. Maybe if this is the wrong one, but this center of center 1, I don't want it to be based on the rows. I want it to be where the diamond is. So the problem is C1 is a cluster, not a connector. I don't know the connector for C1 is the problem I think I have. If I did, I could just ask it, what's your center? And that would be halfway between its top and bottom lines. So I think what I want to do here is somehow get the connector for C1. Yeah. Okay. What can I do to move it forward 15 minutes worth today? Yeah, that's right. Tuesday. All right. So I want to can I get connector 1 out of this thing? Like, I feel like I should be able to take the cluster. I feel like I should be able to say, C1, you're a cluster. I'm going to change these names. That'll be a small step forward. Because C cluster and C connector is getting a little confusing. Unfortunately, it makes the lines a little longer. Okay. So I want to say cluster 1, what's your connector? By the way, I also need to accumulate the whole list of connectors. Maybe. So the other idea I had was connectors, I could make them know their children. And yeah, do the connectors keep their cluster? They don't. They know their ID, their sequence number, and they know the sequence numbers of their descendant leaves. But I don't even think I want the cluster. I mean, really, I am just trying to provide the arithmetic so the view doesn't have to. So this was a way to move something that I could have calculated all this in the view, but it is about line number, X and Y coordinates and stuff. But I'm pulling it out here into production side, or the model side, I guess. But it's more of a model of the view than it is a model of the stuff. Can I find the connector from the sequence number? Well, in principle, yeah, I guess I can, right? I mean, I've got this list of rows coming back. These are all the connectors for cluster 1. And so I could find, I know cluster 1's sequence number, I can just ask. Okay, everybody has one. So I could ask every element in here, hey, give me the one that is corresponds to C1. So I think it's an inefficient way to do it, but would it find it? I think it would. Okay. So would that help? Well, it certainly would. Because this branch, instead of center one, he should be cluster one, connector one dot top. Connector one dot center. Okay. All right. Let's see if we can do that. Okay, so I'm going to extract, I'm going to extract this variable. Oops. Connectors for cluster one. Can I get both connectors one? Okay, connectors one. All right, now I'm going to extract out connectors two. Okay, so now I have that list. All right. Center one, the only reason I use it, excuse me, let's make sure it's where I use it. No match. Okay, well, that's wrong. Because I use it down here, center one. And that's all I do with it. Okay, so now let's make this. Okay, well, I'm going to leave that there for a moment, but I'm going to comment those out. Okay, so now I think your notion is connectors one dot contents okay, he's a list of connectors dot firstware can sorry, I think I messed up something doing that. Dot firstware that takes a function returning a Boolean. Dot first where $0 dot sequence number. What's $0? Let's say item in $0. Oh, I did mean item. Item is a connector, right? Item dot should be Sorry, what is item? Oh, it should be a connector dot ID. Okay. Equals cluster 1 dot sequence number. Okay. So I've got center 1. Okay, so if I got the cluster, now that should be a optional cluster. All right, connector. Okay. Bang dot center. Okay, I think that's what we're saying. So this is an experiment. And then center 2. Connectors 2 contents in cluster 2 dot sequence number. Okay, and I'll just run because we're doing this visually. And then we'll deal with the rest tomorrow. Pretty much in any case. All right, let's take our smaller one, which seemed plenty big enough to show the problems. Boom. Okay. Connectors 1 is built from cluster 1. Okay, well, the problem is when you're a leaf, connectors for a leaf is empty, right? Yeah, so we get a list of empty stuff back. Okay. Well, else starting row. And that's based on this, and then this has to be this one. Double edit. Okay, let's stop. Okay, data center. Okay, is that better? Starting row plus cluster 1 elements count. Okay. Again, we're going at this a weird way to get it, but I think your insight is right that we'll get it, and I believe we will, but we'll see. All right. That is better, right? It's still, they're still intersecting horizontally, but this line is going to the center of this diamond now. All right, let's open our big file. Okay, that is doing better. Yeah, so I think, you're definitely right. Going that connector center turned out to be useless, but the connector center of each one is right. I think we can manipulate this into something better. Okay. Now this, so if I had slid out this line had slid over just past the diamond, one little tick past, maybe that little bit much, the shape of this would look a lot better. You can't tell. Well, I guess that is a little bit to the left, isn't it? Okay. Yeah, they definitely are. Okay. So I don't think this is going to fail the tests. No, we might have some tests that fail. So we'll treat that as an experiment and then work our way back out. No? Okay, so our tests are not sensitive enough to tell whether the 3D connectors point to the right place. Okay, and that definitely that's purely on my misunderstanding of what was being connected where, I guess. That I thought if it was right, usually if things are right recursively, the leaf is right and the next level's right, then all the other levels are right. But in this case, it was not the case. The first level connected based on these lines. The center of the lines is also the center of the line segment for one that's only 2 wide. Well, the connectors, I believe we have tests for connectors because I pulled them. I'm treating those as sort of domain. Well, I know how to do that, right? Let's command that. Yeah, we have connectors tests. I don't think we have connector tests because it's really pretty boring. Yeah. Okay, there's no comparable file. Okay, but this one does test, some relatively, I mean, we have 5 nodes in our thing and 5 nodes here, so it's not nothing. I think we had a pretty good sized one here. Yeah, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes, and yeah. So it's not untested, but it's not tested enough. Like I said, I'm pretty sure we had things simple enough and only verified, the 1 element, 2 element, and then many was just sort of like, well, if it's all recursively right, let's try it and see. But I didn't get a complicated enough case to show what we had in our live data. Okay, so thank you as always for everybody else and for you as well. For all of you, next time is tomorrow, Tuesday, 2 to 4:30 p.m. Eastern Time, Eastern Daylight, or 6 to 8:30 p.m. UTC, and I'm confident we can make the rest of this go. So the driving tests were 2 levels, and I think we did kind of a confirmation test with. This is C3 level. It may be one more level would reveal it here, but this is the example we had on the page, our default example with the 3 levels of 1, 2, 7, 8, 10, 11 connecting. Yeah, so it just wasn't enough. But anyway, we're out of time. We'll see you tomorrow or in the future, I hope. And have a good evening. Take care. Bye-bye.